Welcome everybody to this session. I'm thrilled to see so many of you here and also people are connected online. My name is Maxime IJslin. I work for IUCN Netherlands. I will be your moderator of today and I will also be giving you the introduction. So my expertise lays in conservation technologies and I came across so many promising technologies the last years. And I think that some of these are real game changers. We have a lot of experience in using tools like remote sensing, camera traps, mobile apps, remote sensing, sound recordings, drones, acoustic monitoring, and much more technologies. And I'm really convinced that we need to use these tools to get better information, and we need to innovate because there are so many big challenges that we need to tackle in the conservation world, and we really need to make use of the technologies available. So in this session, I want to show you a few of the tested applications which can support your conservation work. I want you to leave the room inspired and motivated to also use conservation technologies to make more conservation impact. So this session will also be publicly live streamed. So if you say something in a microphone, then people will hear that and they will also see you with the cameras. Tom, are you ready for the video? This is part of Iceland, made by a fixed wing drone. Next slide. Next slide and next slide. So the question that we will be answering today is how can innovative digital technologies contribute to your conservation outcomes? That's the main question of today. So we have in total 4 amazing speakers. 2 are here on site and 2 are now in the Zoom room. They're presenting online. They come from all over the world and they all have great technologies. They will explain their cases. This session is meant by professionals that use technologies on a daily basis, but also for people that just want to know a bit more about everything and are just interested. It doesn't matter if you work for a local CSO or a big business or an international NGO. I think that all these technologies are of interest to you. So next slide, please. So in this session, I will give the introduction. Then we have 4 expert speakers, starting with, next slide, Jorn Dallinga of WWF about early warning systems for deforestation. Then we have Maxime Jondo, all the way from Benin, who will talk about how he's using drones for his lobby and advocacy work. Then we have Merlijn van Weert from the Mabuaya Foundation about his community-based monitoring work in the Philippines. And then, last but not least, we have a surprise speaker. So that's very exciting. Next slide, please. And then this is all followed by a Q&A by you. So I need to have your questions. If you have any questions, write them down, remember them, so you can ask them to the panel afterwards. So just let's start at the beginning. So why do we actually need technology in conservation? Well, basically, you want to apply technology because you want to have better information to make decisions on. There's so many mega trends developing in technology, and the pace of these technological developments are accelerating. And this is giving us unprecedented opportunities for nature conservation to get more information, more detailed, more accurate, more precise, more frequent information, and also at a lower cost. So at IUCN Netherlands, we are interested in monitoring mostly the trend and the state of ecosystems, and also the drivers of environmental change, so we can make better conservation strategies in the landscapes that we work. A disclaimer is that we also always see technology as a solution in a wider conservation story. It's not a silver bullet. It's not going to solve everything, of course, but it can be having a really big impact because you just have better information to make decisions with. Next slide. So we're talking all the time about conservation technologies, but what are we meaning with this? What do we think about? Well, there's not a clear definition, but my definition is that you use technology to make a conservation impact. And mostly this is done by using technology to improve your understanding of ecological processes, or you want to use it to improve your project management. For instance, you want to do your impact monitoring, or you want to strategize better, or you want to use it for communication and networking purposes. So there are several types of conservation technologies. There are low tech, medium tech, high tech, and basically you can make a graph. You can use on the x-axis, you can, previous slide. On the x-axis, you can have the information flow, and on the y-axis, you have the money or the time to learn or the electricity use. And in the left lower corner, it's more the basic tools, the low-tech tools, which always work. They're being used all over the world, mainly in resource poor areas. They're very reliable, but they're also very easy to use. Then you have medium tech tools, which combine a piece of hardware with a piece of software. And this combination is already a bit complex, especially in resource poor areas, because you need some more money and time to learn and more electricity than, for instance, a paper form or drawings or story-based monitoring. Examples of these medium tech tools are drones, camera traps, acoustic monitoring, remote sensing, GIS, apps, crowdsourced data collection, GPS tracking. These are all widely used already, I think. And then last but not least, we also have the high-tech tools, which have a lot of information flows. They require a lot of energy use and time to learn, and a lot of investment they take to develop these. Those are mostly very high risk and high reward projects, mainly done by big international organizations. These are mostly software based. Yeah, so I think that this is a nice continuum to see what kind of technology is appropriate for your organization to use, dependent on the money you have, or the time to learn, or the electricity availability that you have. Next slide. So just to conclude my introduction, it's quite small, but does anybody knows what this graphs means? No, it's the, but I'm sure you've heard of it. It is Moore's law. In a graph, it's saying that the transistor count on chips is doubling every 2 years since the 1970s. It's not a real law, but it just happens to be like this, that it doubles every 2 years. And this means that the future is very bright for conservation technologies, because we can have results with even more higher accuracy, higher resolution. We can expect higher frequency of information flows at a lower price. So what I really hope, and what we're really working on at IUCN Netherlands, is to bring this high-tech solutions to the grassroots level, so that also the people that work in the front line of conservation, that they can also use these very high-tech technologies. But the thing is, we need to make the complex things more easy to use for them. And yeah, we're working on this, and the only way to achieve this is to collaborate together with the tech sector, with the finance sector, with policymakers, with businesses, to scale up projects, to simplify complex technologies, so these can be made available at the grassroots level. Last but not least, we also should take into account that many more technologies will develop now and in the future, and there will be a lot of advantages and disadvantages with these technologies. In the future, we have to expect also stronger regulations. For instance, drone regulation. We also have ethical issues, for instance, around genome editing. We also have hackers and digital security that we should take into account, and maybe even bans on Chinese hardware will follow in Europe. So these are also developments that we should watch. So going forward, we have some amazing speakers right now. I want to hand over to our first speaker. The first one is Jorn Dallinga. He works at WWF in the Netherlands. He will talk about the early warning system program, which he's using in the Global South to predict and prevent illegal deforestation in tropical forests. He's the digital innovation lead at WWF in Netherlands, and he has a great presentation. So big applause for Jorn.
Hi everyone. I'll just wait a second before the screen is sharing my presentation. All right, thanks. Awesome to be here, guys. I hope I can inspire you from this virtual room and from my little house office in the Netherlands. I hope I can bring you some inspiration back home on what big data and AI is doing at WWF Netherlands. So my presentation today is about the early warning system to predict and prevent deforestation. It will take about 20 minutes, and hopefully we can have some interaction during the presentation. But otherwise, I'm happy to take some questions during the Q&A later on. Next slide, please. So we all know the deforestation problem, right? It has been a lot in the news lately worldwide. So we lose a lot of forest every year, about the size of Portugal, accompanied with a lot of CO2 output, and it's disrupting livelihoods worldwide. The early warning system program is not only a tool, it's a program as a whole. That means we work a lot with stakeholders on the ground, but we need to have a problem to tackle. Obviously, the deforestation problem is a big one. So we focus mainly on illegal deforestation. So this system as a program focuses on that specific problem. And I will take you on a tour a bit to see some examples how some countries have tried to tackle this illegal deforestation problem using this system. Let me kick off with a small movie on the next slide.
There are a variety of existing forest monitoring systems using satellite data. Most of them have a focus on detecting deforestation after this has happened. But then the damage has already been done. As prevention is better than a cure, we are developing a system that predicts illegal deforestation and provides an action protocol for land managers. An early warning system for early detection and predicting illegal deforestation through machine learning and big data. If we can detect early indicators of deforestation, such as road and canal development, we can predict areas that are in high risk of illegal deforestation. This enables us to take action before the damage has been done or in the early stages of ongoing illegal deforestation. If we know where to expect illegal deforestation, then all stakeholders receive an alert with options. This alert has to be designed for taking immediate action. Then we have enough evidence to start interventions to prevent illegal deforestation.
All right, cool. Next slide, please. So if we would plot that movie bit on a animation, right, on a, let's say a comic book even, if you read from the top left, the idea is that somewhere in the rainforest, something is going to happen, right? So some form of deforestation, specifically illegal deforestation, is going to happen. So that could be a road, right? So they are making preparations to start logging by building a road. They haven't built it yet, but they intend to build it. And then this system helps to identify where that might be and even how much deforestation might follow in the coming months. So in this case, Anisha is behind a computer and she receives this alert from the system that a new road is going to be developed, and she's sending an alert to a forest ranger, bottom left. And this forest ranger gets an alert on the phone and is asked to head out to that forest, to that location, and take a look, have a look around and see what's happening and sees if these activities are already taking place or might happen in the near future. And as an example intervention, what one could do is, for example, increase this region or this area in their patrol listing. So have a high risk area of deforestation included in their patrols that they might not have done so before. So this is as a whole a bit of the idea of preventing deforestation instead of being often too late, where, for example, deforestation on a large scale has already taken place. So let me walk you a bit through the technology behind this. Next slide, please. So the technology is based on radar data. So that's Sentinel-1. Let's start on the left of this image, number 1. So all this historic data has been collected over the last couple of years, how and where deforestation has happened. All this data is then combined at step 2, combined with all other forms of open and publicly available sorts of big data. So think of elevation data, think of forms of socioeconomic data, such as population density maps, but also other forms of satellite data, such as land cover maps. So where are, for example, palm oil mills, or where are, for example, the mangroves along the coast? So all this data is then combined, collected, and put into a machine learning model at step 3. Now, this model then trains itself based on the historical patterns of how deforestation has happened, but how this deforestation also links to these indicators that I just described, right? So, for example, deforestation might happen often closer to roads, closer to more densely populated areas. So the model now learns and can identify from the past where in the future deforestation might happen. At step 4, then it spits out, so to speak, this forest that is at risk of deforestation, of imminent deforestation. Next slide, please. I have 1 or 2 more technical slides, a bit to just give you a feel of how it looks like for a stakeholder in the field. So the deforestation data itself is at a resolution of 15 by 50 meters. Now, for those who have been in the forest or work on a daily basis in the forest, that's basically a very big tree crown, right? So being able to predict at that resolution is very challenging. However, the deforestation data itself is at that resolution. But to predict is very challenging. So what we do is in the middle of this slide is we down sample the deforestation data or the predictions to a 480 by 480 meters hot zone. So you see a bit of a bigger squares, right? So now we predict on a bit of a bigger square, so close to 500 by 500 meters, using a max pooling technology. So what this essentially means is that within one of those hot zones, we expect deforestation to happen over the coming 6 months. And it doesn't mean that the whole hot zone has to disappear, but it does mean that one or more pixels in that hot zone is most likely to be deforested within 6 months. The model performance is then scored based on the user accuracy. So for example, we can see which predictions were correct, but which were also false positives or even false negatives. And the model learns from this. Let me just showcase that a bit on the next slide, how it does it. Next slide, please. So as I just mentioned, we predict on a 6-month basis. So between month 1 and month 6, deforestation is most likely to happen within those hot zones. And we do that with quite an accuracy. So that's a 80% user accuracy. So 8 out of 10 of those hot zones are going to experience deforestation within the coming 6 months. A side note to that is the recall. So there's a detection rate of 50%. And what that essentially means is that we can predict 50% of deforestation over the course of 6 months with that 80% accuracy. So what we try to do there is update every month our predictions in order to capture also the deforestation that we miss with our predictions. Now, if there's some data scientists in the audience, we use assembled trees. It's an extreme gradient boosting method. Our partners are very familiar with this. Universities and then consultancies are very familiar with this type of modeling. We also tried some different tests, such as neural networks, but this particular machine learning model is the best performer so far to predict deforestation. Next slide, please. This is an animation. It's actually Sentinel-1 from one of our data providers, Starvision. What you see here is deforestation happening updated every 6 to 12 days. But you also see degradation. So in yellow, you see the deforestation happening, and the shades of green indicate the level of degradation. You see different patterns happening all over the map. From top left, it seems to be a bit more organized, with logging roads most likely taking place. Bottom right seems to be a bit more disorganized as deforestation and degradation follows. Now, what the machine learning model does is tries to learn from this landscape, for example, taking connectivity into account, but also the aggregation of forest, or even different patches in the landscape, or how degradation precedes deforestation, and then learns to apply this into its predictive model. If you hit the next slide button. As an example, you see for site A, it's a bit more organized deforestation, it seems. And at site B, it seems to be a bit more disorganized. It seems to be probably a bit more informal. One can think of, in this case, of informal mining that does need a bit of a road, but doesn't need a lot of logging roads. So all these distinctive patterns of deforestation, the model tries to take into account the best it can. Next slide, please. All right, so let's see how actually these predictions simply visualized for the stakeholders looks like on a map. So this is just deforestation and degradation of the last 5 years somewhere on Borneo. Dark red is deforestation and forest degradation is indicated here in orange. So let's plot our hot zones of where we're going to expect deforestation within the coming 6 months. Next slide, please. So these are the hot zones, right? We just discussed these. We visualize them a bit more simple here because they can also indicate how much deforestation is going to take place there. But this is what stakeholders see on a map that helps them to inform their decision making in terms of where do we need to go in the coming 6 months to avoid the most deforestation if deemed informal or if deemed illegal. As you can see, there's a lot of deforestation happening more sporadically across the map. So these hot zones can direct your patrols or can direct other types of interventions to prevent, ideally, the most deforestation. And if you push the next button, the next slide, you will see where deforestation took place 6 months later, right? So hot zones, again, keep in mind, 80% of them are correct, but they don't deforest entirely. So they can be deforested, just only 20%, but they can also be deforested more than 50%. So the top right spot on the map, you can see that a lot of predictions are clustered there together, and also a lot of deforestation occurred there. And this is the idea behind the early warning system. It helps stakeholders like governments, the private sector, and even communities to manage their forests more effectively and more efficient by really focusing their resources they have so scarce to go to the places that might experience the most deforestation on their landscapes. Next slide, please. And this is a typical end-to-end process. So put yourself in the shoes of a forest manager or even a national park ranger. You have this front-end dashboard, a simply map. So think of Google Maps. It's a bit more advanced than that, of course, but that helps visualize how it looks like. And you look at the map and you see these predictions being uploaded. So this is from now on within 6 months where deforestation is going to happen. On step 2, the area manager, it tries to really combine those predictions with other forms of contextual data. So, for example, where are permits? Where is it deemed illegal to deforest, and where it's also legal, right? And how do you prioritize certain areas? For example, are there high conservation value areas or high biodiversity areas, high carbon stock areas? So, which area do you prioritize over the other? Because you can't visit all of them. On step 3, the area manager makes a decision and uploads a set of investigation points to a tracking app, to a mobile app that the users have access to, and then sends patrol teams with step 4 into the field to verify either deforestation or upcoming deforestation in the field. Then the field team take photos, they complete a survey, and come back to the area manager at step 5 and show him the investigation report, and they collectively think of an intervention, what one could do to either prevent or halt the illegal deforestation that is taking place. And overall, at step 6, we try to monitor all the interventions and ongoing actions on that same web dashboard so that everyone has access to the same information, but can also update each other on the actions. Next slide, please. So top left, you see the same image that I highlighted in the previous slides. So the challenge that we often see is that it's quite hard sometimes, if deforestation hasn't taken place yet, what could you do to prevent it? There are some factors that in this example could be taken into account, right? So a national park, for example, it's not allowed to cut trees, so it's illegal. For example, the area manager knows that artisanal mining in the area takes place, but the location is also quite far from the office, right? It's 600 kilometers from the office. And the weather does not always allow access. So, for example, the rainy season, for example, floods a lot of the roads, which allow park rangers to not access that specific area to make any interventions. So these are the actual types of circumstances that a lot of the mainly national governments have to work with in order to go, for example, to some of these locations. But you have to think of an intervention of what one could do to halt upcoming deforestation. I'm not sure if we have some time left, Maxime, to ask one or two type of interventions from the audience. Previous slide, please. If we don't have time, then we can move any questions to the Q&A.
Let's move it to the Q&A.
All right, thank you. Next slide, please. So some of the actions that we've heard so far from some of our countries is that they place, for example, more focused patrols. You've heard that before, but also to engage in dialogue with communities to establish the challenge if, for example, communities are doing what is deemed illegal by the national framework of deforestation. Often what arises from that is boundary discussions. So who owns what plot and who manages what plot. One could also think of camera placement. So if the location is indeed far from the office, you could place cameras or other sensors to indicate when deforestation is actually taking place. And more broader discussions are also with communities on alternative livelihoods. So, for example, we've seen examples where gardens from communities are extending into national park territory. But those gardens, the communities rely on that as their livelihood. So what could you provide as an alternative for their income and their livelihood? Next slide, please. One of my last slides is that we're actually doing this system in several countries, right? So it's in Kalimantan, Indonesia, in Gabon and Suriname. And then Gabon is really making a lot of progress. They just finished a pilot and they're very enthusiastic on how this system helps aim their resources more effectively. Kalimantan also has a lot of examples on how patrols are reallocated to more prioritized areas. Suriname has some interesting examples, mainly on that the locations they visited to did not experience that deforestation yet. So here is that black box thinking a bit on okay, what could one do to think of an intervention to avoid deforestation when it hasn't taken place yet. Next slide, please. Realizing I'm running out of time. The early warning system program is active in 5 countries. 3 of them are running a pilot together with the national governments, but also with more provincial stakeholders, such as universities or organizations. In Sarawak, Kalimantan, we're quite active. Gabon has just finished their pilot, so we're evaluating their results. And in Guyana, Suriname, we're starting or working on a pilot. We're hoping to expand this program to other tropical forests that experience a lot of illegal deforestation. And I'm very curious to hear from you guys how you would see this program work for either different types of ecosystems or even in your current work as a predictive model. Next slide, please. So thanks all. I hope it inspired you a bit on what AI and big data is doing nowadays with some of the countries we're working in. And I'm very keen on the next sessions. Over to you, Maxime.
Wow, thank you, Jorn. Amazing, this early warning system. This very promising high-tech solution. It's also a great example on how we in the Netherlands can help save tropical forest a bit in the global south. So if you have any questions for Jorn, remind them, write them down, then we can ask him during the panel discussion your question. I would now like to hand over to our next speaker, all the way from Benin. It's Maxime Njondo. He's the director of bees in Benin. I know him for many years already. I gave him a drone training as well, together with the staff, and they are mastering the drones now. And they have they're making impact with using the drone for lobby and advocacy. They are improving the fisheries regulations right now in Benin using the drone. So a big applause for Maxime.
Thank you, Maxime. Hello, everyone. We will talk today about what we call with Maxime power of visualization. We are in Benin. Benin is in Western Africa. We want to show you how we use drones to lobby for law enforcement in Benin. We work within the south of Benin is a Ramsar site. Most of the south is an coastal area, which is a Ramsar site, and which is currently a map and biosphere reserve. Next slide, please. Okay, which is currently a man and biosphere reserve. We have along the coast the man and biosphere reserve of the Mono, who bordering with Togo, and we also have a newly one, which is Manon Biosphere Reserve of Leweme, bordering Nigeria. So most part of the south of Benin is now Manon Biosphere Reserve, which means that we need to comply with international regulation to protect the environment, but also to consider the people within those reserves. And what we need to do is to work with our local government so that what is produced as food and how these reserves are managed will be not only in order to protect the biodiversity, the important biodiversity of the site, but also to provide livelihood alternative for the people that in the reserve. And as you probably know, most of the time, our people depend on the natural reserve for their survival. And sometimes they are, let's say they have no other alternatives than destroying, which means that, or using the natural reserve they have because they depend on it for their survival. And when we are working with our local authorities, we from civil society side, we need to take this into account that we are not talking about let's protect the environment, but let's work together with the community on how to protect the biodiversity, the natural resources of the two reserves for the future generation. As you can see, most people depend on this for their survival, but also as we are really close to Nigeria, which is a really big country, most of the food or most of products from Benin are sent to Nigeria. So the demand is becoming high. And then people within the reserve, as they need money, of course. So they are producing more and more. And we need now to work with them and also with our local authorities to see how to protect the environment. And other problem we have within the reserve, because for the reserve of the Weme, for instance, we have the invasive species that we call the water hyacinth, which is a really serious problem for the local communities, because while those species, those invasive species, while it's occur and spread over the lake, they have no alternative for transportation, for fisheries. So most of the time have nothing else to do, so that stay home. If they stay home, they may go to the forest and cut the forest and cut the trees or poaching. So we need to think about what is the real problem that are making them becoming poachers or illegal logging. And we also have dumping into the lake directly without any control. And was it because our local authorities, they don't know it or they can't see it, or what is the problem? And then, as you can see, we have urbanization, let's say uncontrolled urbanization. More and more people are now setting around and also within the lake, because they used to put sand and waste to have land, and then they build the houses on it. So there is a serious problem. The problem we also have is what we call the Acadia. That's what we work with the fisheries administration with Maxime when he came to Benin. In Benin, Lake Nokwe is one of the most productive in Western Africa. And it is a big lake, shallow lake, that is tributary to the ocean sea. And as you can see from this picture on my right, it's an artificial system where local communities, they put branches on the lake. And by the time it produces some phytoplankton, and the fish comes and stay, let's say for 3, 6, even for a year. And then they come after a while to harvest the fish. And they're surrounded with nets and they harvest it. The problem is that's become more and more important in in the lake and spreading all over. That's because, of course, turbidity of the water. That's cause sedimentation, and that's cause, of course, visual pollution, as you can see it from here. And the big issue we have is that it's a cause of conflict between all those who can afford it. I mean, it requires a lot of money to maintain it, to have manpower to maintain it, to buy the branches from the continent, from transportation, buying the heavy nets. So there are some, let's say, an elite class of people that can afford it, and the majority of a small fishery that can afford it. So there is a big conflict between those two classes of fishermen. And sometimes the one, because when the poor one, when they go to the lake on the morning, they can just come back home with 10 to 20 fish per day. And those who are managing the akaja can trap the fish and prevent the fish to migrate. So there is a big conflict that we are trying to solve with them. And what we need to know is that this technique is forbidden since 1972, but no one applied in the field. Because of course, most of the people living there are voters for our leaders. So it's difficult for them to take action and say, okay, let's do it. You are not allowed to do it. We from the CSO perspective, we are not the police. Our aim is to preserve the biodiversity of the site, but also for the people, as I say. So it's a natural resources. That will be, it's available for everybody, not for the single person that can afford it because he has money. So we work with the Ministry Officer of Fisheries in Benin, with the Ministry of Environment. And what we did is that we discussed with IUCN, mostly with Maxime. Maxime came to Benin, and first we have a training of how to operate a drone. We buy a DJI Phantom 3. And he came to Benin, and not only we train a bees staff, but also we train the fisheries administration staff, because the aim behind it is we want to collaborate with them as national government body to work on the fisheries system, not as a CSO, because we are not the police, we don't have this kind of power, but they do. So Maxime came and we built the capacity of those men and how to operate drone. And now they have their own drone. They have 2 own drones. And most of the time they goes to the field with us. And after the fisheries administration training, we also train the capacity of our staff in the field. And then what we did is just, we mapped the whole lake area. Of course, it's not easy with the DJI Phantom because it has an autonomy of half an hour. So it's required a lot of batteries. And when you go to the field, you can also cover, let's say, 2 to 3 hours operation per day, and you need to come back home to charge the batteries again. And that, so it's take a long time to cover most part of the lake, but we did it. It's the time, but we did it. And what we did is that we came back to the Minister of Fisheries, and he was impressed on how it can look at from above, how the system is occupying the whole lake. And when the new president of Benin, and I knew it's almost 6 years again, when he came, he was worried about why Benin no more producing shrimps. And people explained to him that because of the spreading of this system, and also the lake is more and more polluted. And he said, okay, you as Minister of Fishery, let's work and bring back the shrimp so that I can export it again. So when the Minister of Fisheries saw how the system is polluting the lake with the over impact of the lake ecosystems. He showed it to the president of the country, and then 3 months later, they decide to remove, next slide, please. They decide to remove all the acacias from the lake. And now it's a long system, because as you can imagine, it's spread all over the lake, so it will take time, but they started, and now even people were put in jail when they were found around those systems. Something that is forbidden since 1972 and no one took action. But when they see that it is a serious problem, and then we have this political will by the president that say, okay, now stop it, let's take action, and they started. And that's how we show that what we call this power visualization is important for people to see what is the problem for themselves, so that we can help them to manage our resource together. Thank you. That's what I want to share with you.
Well done, Max. You can take a seat. Yes, thank you, Max. This is a great example of how a local CSO can make an impact with this relatively simple technology like a drone. So let's hand over to our next speaker, Merlijn van Weert from the Mabuhay Foundation in the Philippines. He is participating online via Zoom, but he prepared a very nice presentation about how he has set up monitoring initiatives in the Philippines together with the communities. So a big applause for Merlijn.
Thanks very much, Maxime. Can you hear me?
Yeah.
Yep. All right. Thanks very much for having me. I'm presenting from the Netherlands, but on behalf of my team in the Philippines, which you see in the right corner of this slide. Next slide, please. Yeah, so we work, the Mabuhay Foundation works in Northeast Luzon, in one of the last areas with remaining tropical forest. Philippines has lost more than 75% of its forest. And we work to conserve some of the rarest animal species of the planet. That includes the Philippine crocodile, the Isabella oriole, the golden-capped flying fox. These are all endemic species, and the green and hawksbill sea turtles. Next slide, please. An area where we work is very inaccessible. This is the Northern Sierra Madre mountain range, and that's why it still has this beautiful forest cover. Next slide, please. And also large coastal and freshwater wetlands. Next slide. And this area is still very important for the first inhabitants of the Philippines, the indigenous Acta people. Next slide. But as elsewhere, habitats are being threatened. The largest driver at the moment is deforestation by landless farmers. They also convert wetlands into rice fields. And unfortunately, we are seeing large-scale development such as this road, which is being constructed right through the inaccessible Northern Sierra Madre mountain area. So this area becomes opened up. And species that become rare as a loss of habitat loss, such as the Philippine deer in this picture, become even rarer as a result of hunting. Next slide. So we work mainly in areas that are heavily human dominated, and therefore we have to work with local communities and local governments. And this is a photograph of Dinan Creek, a very small creek. You might see it with a small buffer zone of forest, and which is one of the main breeding areas of the Philippine crocodile. Next slide. What we try to do is work with local communities in land use planning. We try to establish or help establishing locally conserved areas with local law enforcement and community wardens. Next slide. And for this, communication is key. So we have a very large and long-term communication and education strategy. We use printed materials. We use arts such as theater shows. We use community meetings. We try to involve all segments of society, including women and the youth. Next slide. But we also try to explore digital technologies, and that's why, of course, I'm in this session. So we basically do 4 things with digital technologies. We use smartphones with our community wardens. We use digital cameras in communities to record land use change and environmental issues. We try to use small video cameras for participatory video filming. And we use drones as well. And we try to do that in a participatory way. So I'm going to show you some examples. Next slide, please. Well, this is a tool that is being used all over the world, so I won't spend too much time on it, but we use smartphones for our community wardens. They use the Cyber Tracker app that we developed using smart software. We use a modified version of the Lawin Forest and Biodiversity Protection System, which has been developed for the Department of Environment and Natural Resources of the Philippines. And we're now also trying to experiment with Cluey, which is an app developed by a Dutch company, Sensing Clues. So the advantage of this is that community wardens can record observations of rare species or of threats in the phone. These are geo-referenced. And it can even be shared real time with law enforcers if you have a good cell phone connection, which is not always the case in the Philippines. Next slide, please. We use small digital cameras. We train community representatives or community people in the use of these cameras. They can be charged with solar power banks in areas where there's no electricity. And we ask people to use these cameras to document environmental issues that they see in their surroundings. Next slide. And this is an example of someone who documented a recent slash and burn field in a community reserve. Next slide. What we then do is we go back to the community, we collect photographs and discuss it with the makers, and then we show this back during community meetings. So these are the photographs made by the community members themselves, and we have a discussion about what we see on the screen. Next slide. We do something similar with small video cameras. This is a training of a flip camera. We provide community members with a small tripod and that camera. And then they can make a small documentary about environmental issues that they see in their surroundings. We have an example of that in the next slide. I hope the video will start.
Mag-play dito ni madama. Basta nakita mo na bagata, madama mag-play dito. Pwede kita marin kita magitan kasi na ngayon focus eh. Kasi di mo nagtatrabaho mo.
Ito yung paset ito yung nasa pak iti buaya. Iso nga ito yung lupok iti kinagat na. Iso nga makita yung kanayon nga nakatabas mo.
Iti buaya, ijay rice field yo, ijay kambayan, kapagayan nyo, anya garot gata iti kuwain nyo. Nya tiarani din nyo.
Next slide, please. Yeah, so this is a really powerful way to document issues and to discuss these issues in community meetings. This is a project of Nicolene Peul, master student of Leiden University. Well, then drones. Well, drones are expensive and a little bit hard to handle still. So we handle the drones ourselves. We show back images during these community meetings, but we try to do participatory droning. And here you see a group of people watching the screen of the remote controller. And that way we can actually have a look at what we see from the air and have a discussion about that on the spot. I made a small video showing how we do that as well. Next slide, please. Then, can you explain that what we see here is what the camera sees?
Oh. Diam kita na. No anya ti makita yo sa tao. Magkita mo niya. Isu di jay.
Nasaan si Kuya Arnold?
Oh.
See? Si Arnold.
Katatawa. Okay na.
Okay na?
Yan. Sige, kata nyo habang kuha tayo. Masih di ka habang pa tayo. Ready? Up! Ayun na!
Laki mag-porno yan. Sila ito ni Ubilawo.
Ano yun? Ano yun?
Yung bahay doon niya.
Ay, bahay mo!
Saan? Sabi ko yan.
Saan?
Ari, bakit pa?
The house of the
Sa di masalansan. Ay, yung kwan nila.
Ganito. Ito, ituro mo dito.
Sa Bahura.
Sa Bahura.
Saan yun?
Maghapos ka doon, maghapos.
Yeah, so this is really a powerful way to have a look at the landscape from the air. In this case, with an indigenous community, we looked at all the areas that are important for hunting and fishing, etc., where the houses are, to back up an ancestral domain claim of this group. Next slide, please. So the aerial images made by drones are very, very powerful. And what we also do is we show these back to communities and discuss the impacts, for example, slash and burn farming on steep mountain slopes, and also show it to local policymakers. One example, last example in the next slide, please. So here we see a drone video in a Isabella Oriole sanctuary in Cagayan province. We see erosion. We see still some forest, very important for the last remaining Isabella orioles. But we see that agriculture is encroaching. So we show this back to communities, but also to local policymakers, and discuss the implications of this. And this was very, this led to immediate action by local government in strengthening law enforcement and reforestation. All right, next slide. And I think that's my last slide. So yeah, so the visualization of these environmental issues using technology is a very powerful way to create more engagement of communities and local governments. I'd like to thank our donors and our co-workers, and thanks for having me, Maxime. Back to you.
Thank you so much, Marlijn. Yeah, big applause. Amazing what you all do with this community-based monitoring, with the drones and the cameras and everything. Great. So if you have any questions, write them down for later, so we can ask it to Marlijn during the panel discussion. I would now like to hand over to our last but not least speaker, Natalie Swan. She has a PhD in conservation science, and now she works at Nature Metrics. She is our surprise speaker because we have not worked with her before. She works at Nature Metrics, and that's a startup growing very quickly because they have an amazing innovation that everybody should know about. Her role is to advise on DNA-based tools for conservation projects. And please give her a big applause.
I hope you can all hear me. Thanks very much for inviting me to be a guest speaker. It's a real pleasure to be here. Let me put the slides up. So yeah, my name is Natalie. I work with Nature Metrics. We specialize in something called environmental DNA to monitor biodiversity. We go to the next slide, please. So we're going to just do a quick run through, and I'll also share an example of some of the work and how this could be applied. So what is environmental DNA? And essentially, we're looking at the genetic material that animals and other organisms leave in their environment. So multicellular organisms are constantly shedding cells that contain DNA into their surrounding environment. And it's everywhere, whether that's in the soil, in the air, and often in the water. And that's through various bodily functions, mucus and feces. Can you go back, please? And so these cells, along with microbes as well that live in the environment, that makes up environmental DNA. And we can capture that and use it to survey species. And the most of the time, the most kind of consistent amount with our work at Nature Metrics, we do that through surveying water samples. Next slide, please. So how does this work in the field? How do we collect this information? Nature Metrics, we actually have custom designed kits. I have one here. We can have a look afterwards. So small kit, and in that kit is everything that you need to take a one eDNA sample. And all you do is draw water up using a syringe, and you then screw it onto a filter and push the water through a filter. And that filter just captures all that material that's been floating around. So the water acts as a soup of genetic material, and we just capture it really simply. To make sure that the DNA doesn't degrade, there's a small amount of preservative solution that you then inject into the filter, and that just stabilizes it and stops it from degrading. And that's it. We have an eDNA sample that is ready to take, send to the lab. And we also have a mobile app, so you can record your data whilst in the field. Next slide, please. Okay, once in the lab, what happens? The first step is to extract and purify the DNA. And then we amplify it. And amplification is basically making millions of copies, because if you think about it, we're dealing with very tiny, tiny trace amounts of DNA. And at the amplification stage is when we choose a taxonomic group that we're going to analyze for. And that can be quite broad, like vertebrates. It can also be more targeted, maybe mammals or just fish. And so once we've amplified the DNA, we're able to sequence it. And we sequence it on a high throughput sequencing platform. And this is basically a machine that reads these sequences and spits out thousands upon thousands, up to millions of sequences. This whole process then is called meta-barcoding. So it's basically the ability to sequence multiple species at one time in these really complex samples. These sequences, the unique sequences that we find in a sample, can then be matched to a species, which is basically found in a genetic reference library or database. And so essentially we end up with something that's recognizable as a species by sample table. And throughout this process, when we extract the DNA, there's usually quite a bit of DNA left over. So we don't use it all during this one analysis. And this means that we can archive it and keep it to perhaps go back and analyze for other groups. And it also provides opportunities for third-party verification of the data. Next slide, please. So let's look at a really nice case study. We worked with WWF Peru in the Peruvian Amazon. And they were basically interested in doing a kind of large landscape level survey to baseline two important conservation species, the pink river dolphin and the Amazon manatee. And they were interested in maybe using some kind of genetic techniques, and we recommended using meta-barcoding, using a vertebrate analysis, because this would hopefully get information on not only these two species, but a lot more on top. Next slide, please. So they went out, the WWF team went out with some members of the Naturemetrics team, and they took samples along over 1,000 kilometers of river, and they took 4 replicate samples at various points. And this these maps basically show the results of the data for those 2 target species. So on the left there, you have the pink river dolphin, and on the right, the manatee. And the red circles indicate a positive detection for that species, while the number indicates the number of detections within those 4 replicates. So you can see there with the dolphin, we've found a lot of dolphin DNA in these waters. Almost every single sample that was taken detected dolphin, and in every replicate. While with the manatee, you can see it was a lot less and congregated around this national park area. And when we map it like this, you can really start to see the difference in the distribution of these 2 species. And we can use this like frequency or occupancy data as a proxy for relative abundance. So we would say, and we know this because I've also worked quite a lot in this region. We know that there's a lot of pink dolphins there. You see them all the time. They're constantly jumping around. And in all my months of working as a biologist in the Peruvian Amazon, I think I've saw a manatee once. They're very difficult to survey. They're very cryptic. They're quite rare. So we're really seeing those kinds of patterns in this data. Next slide, please. But what else did we find? So this survey effort was probably equal to what would be a normal dolphin survey, where you would go out and just count the dolphins. So they just went out along the river. So for this survey effort, not only did we get that information on those, we found a total of 675 vertebrate species. If you click again, please. And that's 155 terrestrial mammals as well. So although we're working in water samples, you get some really incredible data on terrestrial vertebrates, including primates, including jaguars, including these species that are really important for conservation and are very difficult and expensive to survey in these kinds of environments. Next slide, please. But of course, this is the Amazon. It's the highest fish biodiversity or freshwater fish biodiversity in the world. And we detected over 370 fish species. This also highlights an important challenge with this method, because we were only able to identify 20% of those 375 species to species level. And this is basically a product of gaps in that reference database. So we're not able to match to sequences because that information hasn't been gathered yet. But that doesn't mean that that information isn't really useful still. Next slide. So even when we're not able to necessarily put a species name to a unique sequence, we might usually able to perhaps do genus or family level. And with this information, we can still understand kind of community composition of such a species-rich group. And that enables us to map these communities and see how they change. So we can map entire ecosystems. We can and look at things like habitat connectivity and things like that. Next slide, please. Now, for me, I think as conservationists in general, we're always talking about the absolute necessity to involve communities, make sure that there's participation across all levels. And what I love about working with eDNA is the ease of sampling means that we can literally put these kits, and we do, into the hands of the people that are living in these environments. We can train them in, half an hour session. We've done it over WhatsApp in different languages. And this means that those people can go out and they can collect this data, and it really democratizes data collection. Next slide, please. But we are scientists, we've tested this, and we generally know some of the issues with citizen scientists in terms of some of the bias and the difficulties with the data. But this kind of shows the value of this approach when we're having citizen scientists or whether it's park rangers or fishermen communities. But we actually did a test, basically a head-to-head with the founder of Nature-Metrics, an eDNA specialist, against a 6-year-old and some other friends and family. So they went out in the UK and they stress tested this. They all went out and collected their samples along with Dr. Kat Bruce. And what we can see here is that there's no difference in the quality of the data. So whoever's collecting this sample is going to get the same replicable, accurate data. And this is a real game changer for this kind of data collection. Next slide, please. So just to kind of give you an overview of what eDNA is offering, we're getting so much more data, more accurate data on more species. We're doing this faster and doing this cheaper as well. If you think about the teams and the specialists and the taxonomists that need to go out, especially into really remote places like the Amazon rainforest. And we can now do it with people that are already on the ground, the stakeholders that are already there, and they're able to collect this incredible amount of data. It's nice as well that, of course, non-invasive, so there's no messing with the organisms themselves. We can just go and collect water and push it through a filter. Of course, there are limitations. So I mentioned there with some of the gaps in the reference databases. This is something that obviously we're actively working with barcoding campaigns to start to build and fill those gaps. And there are a few other limitations, but this is a really exciting field and the innovation is pretty constant. A lot of the limitations can also be addressed through accurate and appropriate survey design, but we're already seeing improvements there all the time. I just want to finish kind of talking about what's next for eDNA. So kind of beyond just these inventories and species lists. When we're able to get this kind of data with hundreds or more data points for species, it starts to open up opportunities to use big data analytics and machine learnings. And we're already working towards this to start to build metrics like ecosystem health metrics to really measure. And this will really help us to achieve kind of global biodiversity targets, whether it's achieving no net loss or net gain for biodiversity, and tracking restoration progress. And it just allows us to really look at nature in a far more holistic way. I think I'm going to stop there. Is that all right? Okay, thank you very much.
Thank you very much, Natalie. Take a seat. So these were our 4 speakers of today. Thank you, Natalie. Great innovation. I'm sure that we will hear much more about this in the future. Now I would like to turn to you if you have any questions for our speakers, also for Merlijn and Jorn. Then this is your opportunity. Yes.
Hello, I'm sorry. I couldn't follow your name, the eDNA lady. So I was just wondering, how quick could you get e-sample analysis done? That's pretty much it.
And what's your name and your organization?
Sorry. My name is Diogo. I'm from Biota. We have a stand here. We're biodiversity and water consultant experts. I think that's it.
So how long does eDNA is viable? How long does it stay?
How long does the analysis take before you get results? Yeah. So obviously the actual surveying and collecting your sample takes about maybe 15 to 20 minutes. The lab time does take a while, in the sense that the meta barcoding, when we're doing this, we usually go about 6 to 8 weeks to get a full report. There are other methods that we use when we perhaps, I think we're all familiar now with PCR. So qPCR is a method to detect one specific species. And we do use that as well for maybe species of conservation concern. And that's a much faster process, as we all know with COVID and PCR tests. There's a much faster turnaround. So for things like that, we can do it within a few days, within a couple of days. Meta barcoding, it's a long process. There are For us, the most important part is the quality controls. It's very susceptible to contamination because of such tiny trace amounts. So having very strict quality controls at every step of our pipelines is really important. And yes, so the answer is around 6 to 8 weeks from when we receive samples is when we have the full report available.
Thank you. Thank you all the speakers for the very interesting and amazing examples of how technology has been applied to conservation. My name is Paulo Masoca. I'm a research associate at Indiana University in Bloomington, in the US, and collaborating with UNESCO in the Amazonian Biosphere Reserves project. We have it standard over here. So I have two questions, one for Madeleine, if I'm not wrong. Natalie, sorry. About existing initiatives to integrate this database, which will allow further identification of the eDNA. And one question or commentary for Jorn, I think. So yeah, there are many, as he said and showed, there are many initiatives to detect deforestation in tropical regions. And actually, nowadays, we can identify where forest loss is happening almost immediately, near real time, right? In a matter of 2 days, 1 week. So I wonder whether this program you're working on could be also applied to identify or to help us to understand why deforestation or forest loss is not happening in those areas of high risk of deforestation that you identify in these models. In that way, I wonder if you can get some clues or tips and learn what to do to avoid deforestation. You know, I hope you understood my question. That's it. Thank you all.
Yeah, thanks for the question. You can hear me, right? Just a mic check. Yep. Interesting question. Probably a big answer to it, but I'll try to keep it short. But feel free to reach out to me via email to continue this discussion. Yes, there are a lot of existing systems out there. Mainly, they use optical data. So that's hampered by clouds. So henceforth, we use with radar that can penetrate those clouds. But on itself, indeed, it's already a quite valuable product, right? You can see every 6 to 12 days where deforestation has happened. But on top of that, stakeholders perceive the added value of predicting is to allocate again those resources, right, to direct to the most prominent locations that are in need of protection. So it helps just that extra step of how to allocate resources. The model itself learns from mistakes. So if, for example, it didn't predict correctly, it takes it up into the next phase of evaluating within the machine learning itself its errors. So it learns. But it's not always, in that sense, easy to explain that the model was incorrect or that the actual intervention has already taken place to prevent deforestation in that location, which makes it a bit tricky to answer that question entirely. But interventions that we have seen that work at some of the locations is really to engage some of the communities that live close by, that are, for example, unaware of certain national laws, and engage them in dialogue to discuss, for example, alternative options. And the example I gave during the presentation was really with the gardens. So having that open dialogue seems to work well. And some examples, I guess, where we were wrong, it's again tricky to explain. The model simply didn't. There's a 20% error rate in that sense, right? So we misclassified 20%. Hopefully that will get better over time, but the model will, of course, keep making mistakes over time and learns and adjusts ideally by itself. The more data we feed, the better the model becomes. I hope I answered your question a little bit, but again, I'm happy to discuss this in more detail later on.
Yeah, thank you, Jorn. I think there was also another question for Natalie about databases.
About accessibility for this kind of data? Was that?
Yeah, could you repeat your question?
Yeah, just about the existing initiatives to integrate. I guess you are working one organization, right? I guess there are many others. So, and you need a common database to identify, for instance, the species.
Yeah. So in terms of the kind of reference databases, there are a few. These are global. These are open access. Better. Yeah. Sorry. And so yeah, when in terms of the barcoding and the sequences and these global reference databases, they are curated by researchers, by organizations all over the world. So they're all accessible. The sequences are there and available. And so every time when we work with projects that are using maybe eDNA and we realize that there are these gaps, and we will provide the opportunity to barcode, all that information gets uploaded and into an open source, an open library. I mean, I'd also like to highlight a recent program that was launched with Naturemetrics along with the IUCN, which is the eBioAtlas, because a lot of our work is, we work with, whether it's WWF and conservation organizations, we also work a lot with private sector clients, for environmental impact assessment. But our eBioAtlas program is kind of a separate program that is aiming to collect around 30,000 eDNA samples to start really filling the gaps for freshwater biodiversity data. And we want to really provide a global data layer for freshwater. So that's just starting now, and we're looking for to unlock kind of private funding to fund that, and that will be creating a database that we want to be open access. It will be available, that data will be available to conservation communities and academic research communities, free, openly available for that. And then a subscription for any kind of private for-profit organizations that would like to use this data, and with any of the kind of fees or subscriptions going directly straight back into the eBioAtlas now, so it becomes a sustainable financial model. So if you'd like to know more about that, because we've been talking about it quite a lot at this conference, and I've got my colleagues here who are the program managers, be very happy to give some more details. But that's a really exciting program that we can't wait to see where it goes.
Thank you, Natalie. Great. Are there more questions? Yes.
Good morning. Is it still morning? Afternoon. Thank you for the very interesting presentations. I'm Astrid van Tevelen. I work at an environmental consultancy in the Netherlands called Ecogroen. It's impressive, all the work you're having in the local communities with the technologies. I appreciated that. My question is to Natalie. You had an impressive list of, I believe, 675 species identified. I assume these are not all aquatic species. So how does that work, that you can do the eDNA for the land-based species? Could you say something about that?
Sure, good question. This is why we like to work with water, because it does capture so much more than just aquatic organisms. But if you can imagine that most things need water to live, so even terrestrial animals and mammals will come to water, whether it's to drink, maybe to swim, to get places. But more than that, rainfall, washes, all that DNA, so it's from feces, so monkeys that are pooping in the trees. With rainfall, that DNA just gets washed straight into the water. So although I would say with the aquatic, especially like in Europe, where the databases are really well filled, we can kind of replicate 10 years of fisheries data with a couple of days of eDNA surveys. So with fishery data and aquatics, we can have really maybe even some good relative abundance information. With the terrestrial data, it is going to be more stochastic, so more random. We'll often perhaps in how we design the surveys to really maximize the chances of detecting these kinds of more terrestrial vertebrates or terrestrial species. But in general, we find that we get some incredible data, and it's because of that. It's because water is life. It all ends up in those water bodies, whether it's a pond, whether it's a lake, whether it's the ocean. We work in marine environments as well. And it's really incredible. We get bat data, monkey data, like a very cryptic, rare terrestrial data, all because it just gets washed straight into those water bodies.
Great. So there's time for one more last question. And otherwise, I have one question for Merlijn. Merlijn, you're working with the communities with cameras and drones. How do you make sure that they're being maintained by the communities and being used in a correct way, and that they're not being damaged or misused?
Yeah, thanks, Maxime. Yeah, that's something that we spend quite some time on thinking. So what we do is we use cheap equipment. We try always to find the sort of best value for money. We use equipment that is usually waterproof or shockproof, smartphones and cameras that are simple to use, that can be charged with solar chargers, because we don't have electricity in most of the communities where we work. We provide extensive training to people. We follow up those trainings. So every field visit of our community organizers, they will revisit those communities, provide more training, see if it all works. We allow personal use. So when we look back at the photographs, then usually half of them are weddings, etc. That's fine. But we always stress the importance of also using it to document environmental issues. And we assume that we will have to replace equipment every 3 years or so. So we include that in our budgets. I hope that answers your question.
Yes, perfect. Thank you, Merlijn. So with this answer, our session has come to an end. It's 1 hour later. I really enjoyed it. I hope that you're all inspired to use also more technology in your work, because they can provide unprecedented opportunities. Just as a closing, I would like to thank also the technical staff and our speakers. Big applause for them. Thank you. And I would like to invite you to remain seated for 1 more minute, because Merlijn made a closing video for us, and which can start now. Of the landscape in the Philippines. Amazing. Thank you, Merlijn. Okay, have a nice day at the conference, and I'll speak to you later.